one way, like making sure you guys are great. So today we're gonna talk about version control and Git. Anyone heard about Git? Yeah, I'm recording. Sorry, earlier I didn't record because, yeah. So you all heard about Git. You used it before in what? I think you used Git. I think Git. Like, yeah, SSC course. How do you like it? How do you like the ability, the lack of ability to tell, Ajahn, I lose my work, I suddenly delete the file. You don't have that anymore. You don't have that option. But since you used it before, now I think we can go relatively quickly. And then we will spend more time with the Q&A, right? And it's okay. You still feel like you don't know how to use it properly. So do I. Actually, there's new features and updates that comes out all the time. So we always learning that. And actually, that's one thing I love about computer science. So sorry, tangential again, but this is one thing that's awesome about our community, right? We like programmer developers, we have to catch up all the time because there's always new tools that come out, right? But yeah, we just need to learn how to actually understand how to use certain things, right? So to motivate, right? But I think I don't, like, since you use it already, hopefully you don't need that much of a motivation. But let's say you're working in a group project and you spend the last 7 days cramming your code in, seems familiar. You finally get everything to work and planning to do a pilot run. And then you create directories to store results and you make a typo. Instead of something, you do rm-if for some reason. You're drunk because you lack of sleep. I don't know. I don't know why. I don't know why anyone would ever try this when you're right about to do a demo. But let's say you don't have a lot of sleep and you type and hit enter. Your brain order your hand to stop, but because you're tired, that signal, I mean, scientifically impossible, but reach your hand later than it's supposed to be, you hit enter. What happened? And what happened after that? I guess another human being crying in a corner with the cloudy thing on top, if it's animation, right? Your stuff is gone. Um, it's actually not physically, it's not reduced to atom, but it's actually there in your hard drive. just to just to make it like technically correct, it's there in the hard drive, but your computer has no way to find that because you basically get rid of the link to that location for the file. It's actually there. It's still, everything is still in your hard drive, trust me. But there's a way how Linux like locate every single file, and when you do rm-if, you lose the ability to locate that file anymore, right? So now it's gone. So sad face, right? Another scenario, you're working on a project, you spend the last same thing, right? And you finally almost get everything together. So, Garan, that's a great question. So I'm gonna go tangential a little bit. The question is, does nothing ever get deleted, right? How many people seen the like movies where, like, say the guy is a hacker or something, and then the FBI come in? What do they usually do? Anyone here old enough to like watch Matrix, like the first Matrix, the movie? That's a long time. That was when I'm a kid. But remember how the like Keanu Reeves actually burned the hard drive by putting that in. I think it's like he put it in the microwave or something, right? So that's one way to actually destroy the file. The thing is, in many cases, right, when you do im-if, right, what the computer actually do is say, okay, I will stop being able to point to that direction and I'll mark that as a free space. Why is that a good thing? Why is it okay to just, for me to just say, hey, that's a free space. I'm not deleting anything. I'm not deleting, flipping all the bits from 1 to 0. I just mark that as free. What's the benefit of that? It saves time. Yes, perfect. That's a perfect answer. It does save time, right? Um, I would compare this saving, cost saving too. Let's say you like you run anyone play SimCity before? Too old again. Sorry for like all this old reference. So let's say it's like a city simulation game and you want to destroy certain part of the city, right? What do you have to do? You have to first delete it, get rid of those building, right? Until it's all collapsed to the ground, and then you build another thing on top of it. In this case, well, you can just overwrite, right? You can always overwrite the location. So why is there a need to actually delete anything, right? And does it hurt at all to not delete it? Like, no, you're not gonna notice it. User is not gonna notice it unless you want to destroy like completely destroy the file, right? So that's what happens when you delete the file. You just lose the link to that location. That location is marked as free so that in the future you can write something on top of it again, right? And that's why sometimes you want to destroy hard drive. I guess microwave is a possible option because anyone don't ever try that. Actually, I'm not gonna say what would happen. Yeah, if you put like those things in the microwave, it will catch fire. And will get destroyed. So yeah. Anyway, is it possible to get files back? Depends. Depends. So there's also now the question about how does the memory space reduce if nothing ever get deleted. Great question. The thing is, while they're not getting deleted, they get flagged as a free space where you can overwrite them. That's how you make up the new space, right? That's how you make up free disk. So any other questions? All right, so now let's go back to our second scenario. You are trying to get rid of one bug. Does this happen in your Python class? You have one bug, you try to get rid of it. In the process, yay, 3 more bugs appear. And now you don't know what's going on. You try to get rid of those, and then you create 10 other bugs. And this is basically what I would do. I would sit silent in the corner. It's like, what's life? Anyone had that scenario happening at all? Oh, you just go skip to that silent corner thing. Like directly go there. You sit silently in a corner with that one bug and you can figure out the solution. So yeah, this thing can happen, right? When you make change to your code, right? It impacts other function calls. It impacts whatever you have, it impacts whatever the other part of the code. It can actually create more bugs. Git would get you the ability to compare each of the version, right? Also these things, like I swear my code worked yesterday. Yeah, these are not valid reasons anymore from this point on. All right, guys. From this point on, you can't just say, hey, I lost all my work. Back it up using version control. And this is basically where and how version control can help, right? So what would be the most primitive version of version control? Can someone tell me the most primitive thing? Like if you don't know Git, if you don't know anything, how do you back up your data? You copy, right? And yes, actually, exactly. Have 10 hard drive and then copy everything, right? And that's what I did as the first and I guess second year, first semester PhD. No, PhD, my bad. Undergraduate student at CMU. I actually make copies. Um, assignment one version one, assignment one version 1.1, assignment one version two. That's what I did, right? Until I learned, oh, that's this thing you can help you. So that's kind of like the primitive form of version control. And then, right, there's invention about the version control system. When you put the word system next to something, it helps with the like building a structure process on how to apply version control, right? Um, it allows you to track all the changes. It allows you to go back in time, right? While we don't have time machine yet, at least you can have a time machine on your code, right? It also track people's individual contribution to the changes, right? So that if you have a group project, now I can see who contribute what, right? I think it was this is an awesome tool for me, for example, to check who is shipping in for each part of the code. And there's multiple version control system available nowadays. I have used, actually, to be honest, now I've used all of them. Mercurial, Subversion, and Git, right? Actually, multiple company use Mercurial. Multiple university back in the day use Subversion, and these days many company and academia and just any developers would use Git, right? These are really handy. Why Git? Git is distributed version control system. Anyone notice the word distributed? What does distributed mean? It is actually kind of, yeah, it's a little bit different. Distributed is kind of everywhere, right? It's a version control system that can happen everywhere. There's a distinct difference between distributed and decentralized. We're not gonna talk about the discussion right now, but just make sure you don't confuse the two terminology together. Decentralized is more like you're not giving control to a central system. You can still have a centralized system that is distributed, right? Where each part of the computing resource would perform its own computation, but the control is still being done in a centralized way, right? That's how Facebook managed the data. That's how Google managed its data. Um, so in any case, so distributed version control system, as you can guess, is everywhere, right? So each local machine, like your laptop, can have your own local copy, right? Imagine this scenario where, let's say you have, how many people have two laptops right now? Or like one desktop for the family, and then you have your own laptop. So anyone, let's say you're in that situation, right? And then yeah, or like gaming and work laptop, but let's say you have to work on a gaming laptop for some reason, and you move to the work laptop, right? Would it be nice so that your work laptop have also the update from the gaming laptop? Because otherwise, if you have to do those things on your own, it's going to be super annoying, right? So distributed VCS allows that. Basically, each machine can have its own local copy. Gaming laptop has its own copy. Your work laptop has another copy. The server, the Cisco server, it also has its own copy. Why not, right? And you can maintain multiple copies on multiple machines. And in this case, you don't have to talk to the central server when you edit. You only use the central server to synchronize so that say, hey, updates from here, so that everyone can see the update. And a good and popular balance is basically allow a good balance, right, of collaboration and also working independently. So this way you don't have to crowd that one single computer. Anyone try pair programming where two of you will sit in front of a single computer and try to program something? Anyone try that before? It's actually useful for some setting, but let's say you can work independently, but you want to kind of merge the code afterward. Distributed VCS is better, right? So Git is one of the most popular VCS, and the benefit is you can basically branch. By branching, basically it means that you create a separate version of your code, and you can merge them together too. You can merge each version of your code afterward, right? It allows flexible workflow. It checks for data integrity so that if someone try to upload some weird, buggy, like corrupted data on your Git repo, right? It checks for that, and it's really fast. Uh, to formally introduce Git, right? The first thing you have to remember is this thing called repository or repo. It's a collection of file and folder with all the version history. That's it. That's what the repo is, where all your files are. along with all the history of the changes. And file history would appear in a snapshot, right? What does snapshot mean? What does snapshot really mean? So anyone play games where, yeah, it's a version, a different version, right? So it's similar to when you play a game. And I love comparing this to a game analogy because I do play games. And I think many of you also at least have seen people playing games before. One thing you can do is save the game, right? For example, let's say you are about to fight a really hard boss, right? Elden Ring. How many people here play Elden Ring before? I haven't played. How is it? So, what are you supposed to do before you are about to commit something dangerous? Save, right? Unless you're crazy and then you are really really good. Uh, you would try to, yeah, it's auto. So yeah, this is similar to taking a snapshot, right? Because if you go fight certain, well, actually, from what I've heard, if you go fight any enemy in Elden Ring, what can happen to you? Yeah, you die, right? Um, so this is similar to taking a snapshot. You develop your code and you have 20 bugs appearing. And I was like, I don't know what's going on here. Let me revert back to that change before I go and commit even more sin and now my code doesn't work. Same thing, right? This snapshot is called a commit. It's called a commit, right? So it's called commit. A repository can have different branches, each with its own history of development. This is basically where this becomes great. You can have your friends coming in, develop their own code, and you can kind of merge them together. And these are the high level overview of the version you can have, right? You have 3 files in the repo. Version 2 have modification on file A and C. Then someone commit version 3, and the only thing that happened is now someone modify file C again. So now you get the second version of file C. Sorry. Then you have version 4 and version 5. So note how originally it's just 3 files. And then whenever you commit new things over, it doesn't store another separate file. What does Git store? It's not a separate file anymore. What is that? What does delta usually mean? This delta 1, delta 2. It stores the changes. Why is it good to store just the changes and not the entire new file? What's the benefit of this? Yes, it saves a lot of space, right? This allows you to basically do a lot of modification and it's actually space efficient. This way you don't have to store every single new version of the file. You just store the diff, right? Which can be just one line inside this 1000 line code, right? Which is nice, right? This is really nice. It's space efficient. So to create a new repo, you can do git init, right? Since you used it before, I'm gonna go quickly through this. What happened when you have git init? It creates this .git directory is a hidden directory. Inside there is all about the configurations. It's all about the information about the repo. Then you can clone an existing repo. What does clone mean? Clone basically make an exact copy, right? As the word suggests, make an exact copy from the remote repository. Let's for the sake of simplicity, let's say these are in the server. So the server hosts a central copy for everyone to clone from. So one thing you can do is to clone from this. Now you have your own local location of these repository, right? So the high level explanation is something like this. What does sandbox mean? Sandbox is that's where you're playing, right? You're building something, you're building a program, and you're trying to check whether it's work or not. And once you have a good version inside your working directory, you want to save it. You want to actually commit a snapshot. One thing you can do to commit a snapshot is you would do git add. Let's say you have file A version 1, right? And you modify that and you have version 2 of the same file, much better. You want to commit this so that you can have the snapshot. You do git add file name. Then when you do git commit would move from index to head. What would that mean? What does it mean? This means that, so over here, when you stage a change, so over here in the index, this is where you tie with staging. Stage mean kind of like a stage, right? Where you stand there. It's kind of like the forefront where you can see the version, but it's not like fully committed. If you want to commit this change, you do git commit -m. This is where in your local computer, you're gonna archive version 2. You're gonna archive version 2. That's what would happen when you want to sync to the server. Whatever's in the head, the committed change would get also uploaded. You can also unstage the change. Let's say you have version 2 inside the stage, right? This is where you have the stage. You say, hey, some bug happened. I want to revert this. Like, I want to unstage the change. You can do git reset. This basically allows you to revert back. And if you want to not reverting back to just the stage, right? You want to discard any change. You want to get rid of version 2. This is bad. Too many bugs in here. You do git reset -hard. That's an option to basically say, hey, put version 1 all the way to my working directory. I don't want to see version 2 anymore. It's bad. You can do git status. It would show you the status of the repository. It would say, hey, these are different files that are already on the stage, file that are modified, but haven't been staged. For example, you modify this file, right? But you forgot to do git add. It will say, hey, that file, I know someone changed it for sure, right? Because I checked someone changed it, but you haven't staged them. So maybe you want to do git add just to make sure you stage them, right? Or you can do git check out the old file to discard change in the working directory. So that's how you can commit and save and archive different versions. The next thing that we have to go over is branching, right? Why do you want to do this branching? Let's say you're running a small tech company, right? This is your company. And you have 2 teams, team 1 and team 2. Team 1 is implementing feature called feature A. Team 2 want to implement feature B. And ideally, right? Ideally, it would make sense so that all the teams can work in parallel. Team 1 would take the code and work on feature A. Team 2 would take the code, work on feature B, right? So in this case, team 1 is basically here, right? Team 1. This is original code. And this is basically where team 2 is, right? In this case, right? To some extent, yes, each Linux distribution, it doesn't use Git, right? But the analogy apply where you have different distribution working on different features, and some of them would enable certain features, some of them would hold back those features and make sure it's stable first and things like that, right? And then the master here is basically what you sell, right? Why? So let me first ask, why team 1 and team 2, when I'm working, I can't I can't modify. I cannot just touch the code that I'm selling right now. Why is that? Why does this make sense? So why does this structure make sense? When you are selling to your customer, what they would see is the master to some, hopefully to some extent, right? It should be a stable version where everyone can take a look at the code and hopefully everything is stable. And then when you're implementing each feature, you might mess up something. So you want to make sure those modifications didn't get applied to this central master that everyone sees. All right, so hopefully it's clear. But then it means that you should be able to switch between each branch. So let's go through the example, right? When you want to check out the master branch, when you go to the master branch, you can say git check out master. Every single file would be the master branch. And if you want to then move to branch one, what would happen is now your repo would basically switch to branch number one, right? And to create a new branch, you just add dash B. When you add dash B, it means that I'm going to create a branch called branch two. Now you have three branches, master, branch one, and branch two. All right. So now let's visualize what does checkout mean. So here's a visualization with the command checkout. See how you do checking out master. When you do git checkout master, you're basically here. And when you do git check out some features, basically you'll be here where now the check out the branch name is some features, right? And this actually does, so now it's just on your own computer, right? This is basically, let's say you have work computer and gaming computer, and your mom was looking, you'll basically, hey, I'm working, I'm not actually on a gaming laptop, right? So you basically want to do some work, you have all the branches, you can switch between branches. Then you switch to the gaming laptop, you were like, okay, I'm almost done with the homework. I want to play a game for a little bit. And then you realize, hey, the deadline is still in 10 minutes. What you can do is now you can work with the remote Git repository, right? Your remote location was your work laptop. Now you need to update the local location. You first pull it over, right? And modify the code. When you modify the code, you have the origin master. Basically, that's like the local, your gaming laptop, right? And then you have your own like branches where you have the development branch and like certain features. So in this case, right, you want to be able to interact. You want to be able to interact and update everyone else, like your work laptop. You want to be able to interact to this remote location, right? So that you can take the code from the master and update the master branch as well. So to work with a remote laptop, repository, right? One command that you need to remember is called pull. Git pull basically would transfer the changes from a remote location. So let's say you use GitHub. Anyone here use GitHub, right? Or the Python class is all GitHub, right? GitHub. Or what? Oh, Python class did use Git. Okay, my bad. Sorry. But you heard about the website called GitHub, right? So it's a website that allows you to actually host your Git repo over there. So it would act like a server where you can put files there and then you can pull to your own machine, your own laptop, right? So that way you have the GitHub website, the back end of GitHub, right, to maintain this version control for you. The overview of Git pull is something like this, right? So let's say this originally you have everything is at the same point. Everyone is on the same page, right? So that's where everyone is. Everyone see this version. This is like snapshot one, like time point one, I guess. Time point one, and then you have time point number two, and you have time point number three. So this is me editing, right? I'm editing the file, and then I want to be able to pull in the changes from the master to here. Now, when you do git pull, basically every changes that the server have, every change that the server have would get pulled to your laptop, right? Basically, you pull all the changes that everyone else, your friends, are making on that repo onto your local laptop. You can also do the reverse. So pull means I want to see all the changes. Push means I want to push all my changes to the server. So it is the reverse direction. Over here, get push. Before pushing, right? It's something like this. Origin master is here. You are here. When you do get push, origin master will be at the same place as you. So basically, this updating the server so that it has your file. And now here is the summary of the workflow, and hopefully this is clear. So hopefully this is basically the most clear. This is GitHub. This is your laptop. All right. Before I explain this figure, are we clear on the left side is your laptop, the right side is GitHub? Are we all clear? Clear. Left side is your laptop, the right side is your GitHub repository. All right. Are we all good with that? Awesome. So one thing you can do, you can, from your laptop workspace, you can stage the change by git add. Git add would stage the change. Git commit would push the change to the head of the laptop repository. Now we are still in the local part, right? No friends that are working on this will see the change yet, but this is locally on your laptop. You can create multiple versions even within your own laptop, right? If you want to skip the two step, git add, git commit, you can do git commit -a. This is the command I do recommend because I use it all the time because I'm lazy, right? I am lazy. So one thing I do is I do git commit -a, every single change push all the way to the local repo, because I mean, most of the time I would stage and then commit anyway. So it's a merge of the two commands. Git reset basically means that I have some changes and I don't like my change, so I want to revert back to the version that I like. Git reset with the commit names means that you can now change to the older version. The older version comes from your previous commit. Your previous commit create the save point. Git reset with the commit name means that I'm gonna load that save point. It's like you play games and you can save, and then you don't like something, you load the game, right? You load from the game. Git push basically would give you the updates to the remote repo. Basically, this, when you do git push and you work with GitHub, basically it would mean that you commit all the changes to GitHub. Now everyone can see your changes. Git fetch is the reverse of that. You pull in the changes someone else has done, it's updated on GitHub. Now it's applied to your laptop, right? Then if you want to do a update from the server all the way to your laptop, you will do git pull. Git pull will bring in the most updated version from GitHub to your own laptop. What would happen? So let me ask you this question from this figure. Let's say this has version 3.1 and your laptop has version 3.2 of the code. You make some changes, your friends make some changes, your friend push to the GitHub first. You are still making changes to your file and you do git pull. What can happen? What can happen in that scenario? Yes, it's a conflict, right? Because you have two different versions and you have to do what? Your friends and you develop codes together, you make edits. Your friend makes other edits, each one in your own laptops, right? So both want to push to the repo. Basically, whoever commit later has to resolve this conflict. The way to resolve conflict is called merge. So there are multiple ways you can merge. The simplest way to merge is called fast forward. Git merge fast forward would basically merge the conflict to wherever is the most future version of this file, right? You fast forward to that version. Simple, right? Simple because everyone is still on the same kind of track changes, right? So you can fast forward to the most updated version. This is basically most of the time, this is the default. But let's say you're here, right? Let's say this is where you are. You make some changes to the same file. Your friends also make changes to the same file. Now you actually have conflict on the same file. In this case, in this case, someone has to merge the file content, right? So let's say you and your friend change the same file. In this case, whoever commit later, whoever do the commit later, has to figure out, okay, how do I combine all these changes together into one final version? So what are the other commands, right? So let's do a quick wrap up because that's basically it for today's lecture. As I promised you, this actually a quick lecture. You have git init, git clone, git status, git log. Log would give you the history of the commit along with the messages. Git add would add a file to the staging area. Git commit would put that to the head of the local repo. Git push would push to the server. Git pull would bring the data to the server. Yes, you can then grab the version history. You can then grab the version history. So you can do git log and forward as an input, but basically pipe it to the grep as the input to grep command. You can do git checkout to retrieve the earlier version of certain file. All right. So that's it for the overview about Git. We make this lecture specifically so that you can use Git as a tool, right? Not as a source of pain, right? This eventually it will originally be a source of pain because you then figure out how to use Git. After you try for like maybe 15-30 minutes, you get used to it actually, and then becomes a really, really useful tool for you going forward. In the foreseeable future. Yes, here. So there was a comment say, can I go back to the previous slide? The slide is on the class website, by the way, so you don't have to always do the screenshot. All right, if you go to Canvas, it's there. Yes, you can also use the Git visualizer. So let me go to GitHub for you as an example, right? Do I have it logged? Yes, I have something logged in here. So if you go to GitHub, right, there's actually multiple things that are handy, right? These are one of my wait. Yeah, so this is basically one of my repository that I host the code that people can take a look at. So if you go to GitHub, you can now see the file structure. It also allows you to put in a README file. Whatever you put in here will get printed down here, right? You can check out each file. Oh, there's only one single version. So this is not a great repo because it's only one commit and that's it. Uh, Yeah, let's look at this. My own. So this is my the I use GitHub.io for to host my personal website. So you can check the index.html right here. This is basically where I the page land, and you can see that hey, there's multiple command here, and you can see the history, right? It would allow you to see, okay, what are the changes that I make, right? And you can click on each of these changes, and you can see the diff, right? Okay, what are the new things I added? You can see the plus sign here. You can see the line number, so it actually tells you the line number that have the changes. You can also create a comment on GitHub to actually put in, hey, something is wrong, or some whatever comments you want to pair up with that particular comment as well, right? And that's kind of like a quick overview of this handy tools. So if you have any other future questions about Git, feel free to check back on the Discord. I'm sure all our TS can GitHub this all fork. No, it's the same question. Sorry, my bad. So that's it for today's lecture.